Greetings, everybody. This video will hopefully explain how I want you to solve problem 7 on exam 3. I want you to solve it according to my hint. And let me bring up that problem. And here's problem 7 on exam 3. And notice you have what's called a carpenter's square in the shape of an L. And with all these center of mass problems, we're assuming that the carpenter's square is uniform, meaning the mass is distributed uniformly. And notice it has the dimensions as given here. Well, in my hint, I tell you to consider the carpenter's square as 3 uniform pieces as shown below. Here I have piece 1 indicated by the red dashed line. So the base is piece 1. Then between the red dashed line and the blue dashed line, that's piece 2. And then the remaining part from the blue dashed line to the top, that's piece 3. So you have to solve it according to that hint, which I'll elaborate on in a minute. Now, what you don't want to do is, in the past, I've gotten a lot of solutions that look like this, where here's this exact same problem, and here's their solution where they break it into 2 pieces as shown, and I get a lot of this stuff. So if you hand in anything even remotely resembling this, you're just going to get a 0. I mean, because that's cheating. Yeah, anyone can go online and download a solution. So again, be warned, if I see anything resembling this, you're just going to get a 0 on that problem. So just keep that in mind. And it's really not a difficult problem if you can follow my hint. All right, so let me bring up my hint. And here it is. So, and I've zoomed in. So you're going to take that uniform, I call it an L, they call it a carpenter's square. And you're going to break it up into, considering of 3 uniform pieces. Piece 1 indicated by the red, piece 2 indicated by the green, and piece 3 indicated by the blue, meaning the color of the numbers. All right, so nothing complicated. Well, notice in my hint, piece 1 and 2, their dimensions, each one is 4 by, and the units are centimeters, which is fine. You do not have to convert. And you'll want to express your center of mass will be in centimeters, and keep it in fractional form. I don't want to see a decimal. But notice piece 1 is 4 by 12. Oh, and again, let me just take one step back. We're going to calculate the center of mass relative to the origin, which is at the lower left right here. The lower, consider that corner of the L to be the coordinate of our, the origin of our coordinate system, the point 0, 0. Nothing complicated. So that's just like we did. And again, this example, let me take a little aside here. This example is really very, very similar to this one that I posted, where we've got this uniform piece of sheet metal shaped as such. And again, we're choosing the origin to be at the actual origin of the coordinate system. And notice, because the piece of sheet metal is uniform and it's shaped as such, each of these squares is identical. And the center of mass, and again, it's 6 squares. One, just going along the bottom row, there's 1, 2, 3, 4, 5, 6. So there's 6 squares. Because the object is uniform, the center of mass of each of the 6 squares lies at its geometric center, indicated by the red dots. So for the first square, just starting at the lower left, and just going across 1, 2, 3, then square 4 here, then the 2 squares at the top, 5 and 6. Well, the center of mass of square 1 is at the point 5, 5. The center of mass of the square 2 is at the point 15, 5, meaning x, y. Likewise, the center of mass of the third square is at 25, 5. And you get the idea. I posted a video explaining this problem. But you're approaching this problem in the exact same way. So divide it up into 3 pieces as I show here. So notice piece 1 and piece 2, notice they're both, piece 1 has dimensions of 4 by 12. Notice, what about piece 2? Well, piece 2 has dimensions of, the width is 4. Remember, we're just looking at piece 2 indicated by the green. The dimensions of piece 2 are, the width is 4 and the length is 12. So piece 2 is also 4 by 12. So therefore, they have to have the same mass because they're exact same size. Just call that mass M. Now notice sheet 3, not sheet 3, piece 3, indicated by the blue number 3, well, it is 4 by 2. So you have. So now you know it's compared to piece 1 and piece 2, remember their mass is the same because they have the same dimensions. But we're calling the mass of 1 and the mass of 2, they each have a mass we'll call M. Well, you know the dimensions of piece 3 is 4 by 2. So you know what its mass is in terms of M. Remember, M is the mass of piece 1 and piece 2. And you know their dimensions. Well, you know the dimension of piece 3. So in terms of, so you compare it to the mass of 1 or 2, you know the mass of piece 3. Okay, now again, I'm referring to the pieces as 1, 2, and 3. Again, 1 is indicated by the red number 1, piece 2, the green number 2, 3, the green number 3. Well, remember, they're uniform. You know where the center of mass of piece 1 is. It's at the coordinate 6, 2. Okay? Well, likewise, you know the coordinate of the center of mass of piece 2. And it's at 2, and the y coordinate, well, I'll let you figure that out. Remember, you need to figure out what is the y coordinate of the geometric center of piece 2. Remember, piece 2 is the green. Okay. Likewise, you know the coordinates of the center of mass of piece 3. Again, now that problem becomes exactly the same as this one, because once you know the coordinates of the CM of each piece, those are the xi, yi's that you use in the summation. And likewise, for the problem on the test, you should be able to get an expression for the total mass M in terms of little m. Now, again, it's not going to be numerically not the same as this, but the method's the same because no different. You know the coordinates of each of the CMs indicated by the red. Those give you the xi, yi's in the two sums. Well, by using my hint, you can determine the xy coordinates. You know, in other words, you can get the xy coordinate of the CM of piece 1, the xy coordinates of the CM of piece 2, and the xy coordinates of the CM of piece 3. Those are the xi, yi's that you use in the summation. You know, piece 1 and piece 2 each have a mass of M. Well, piece 3, obviously its mass is going to be smaller than M because it's dimensions, but you should know exactly what fraction of M the mass of piece 3 is. And so you're going to have, in both summations, you should have, because remember, you're doing the sum of the mi, xi's to get the, 1 over total mass times the sum of the mi, xi's. That's going to give you the xcm. Likewise, 1 over big M, sum of the mi, yi's. Well, you're going to have 3 terms. In each sum, you're going to have 3 terms because you have 3, you broke the L into 3 uniform pieces. Here we actually had 6 terms because the sheet metal is broken into 6 uniform pieces. And so it makes this problem really very straightforward. So again, don't give me any of that other malarkey that I showed you. You're doing it, the method is exactly the same as this example. And now based on my hint, you shouldn't have any trouble with it. Again, because you're breaking it up as such. Alrighty, let me go ahead and stop this video and get it posted.